Hello everyone, this is the first video of Basics in Analytical Chemistry, Paper 1, Unit 3. Now before we go on to learn more about chemical analysis, one needs to understand the difference between analytical chemistry and chemical analysis. Now, when we talk about chemical analysis, one thing comes into your mind that chemical analysis is usually performed to carry out a qualitative analysis or to get a quantitative information. Do you have any idea about the qualitative and quantitative analysis? Just have a look at this picture that is in front of you. When you look at this picture, you will get some idea about what is meant by qualitative and quantitative analysis. You might have guessed it correctly. Qualitative analysis means when you find out what is present, and quantitative analysis is when you find out how much is present. So qualitative is what is present and quantitative is how much present. Can you recollect any qualitative and quantitative experiments that you have done in the laboratory? Yes, organic spotting and semi-micro both fall under qualitative analysis. Titometry and gravimetry fall under quantitative analysis. Then what is meant by analytical chemistry? Analytical chemistry provides methods and tools needed for insight into our material world for answering basic question about a material. That means if you want to do an analysis, which is the best analysis for a particular compound, or if some existing method is available, how can you extend that method for different types of materials? That answer can be given by analytical chemistry. So analytical chemistry is useful. Some examples are listed over here. It is useful in clinical laboratory tests for diagnosis, in industry for testing raw material, for the quality control of the product, in environmental field for testing of suspected contaminants, and in food industry for finding out nutritional value of food. Whenever any analysis is carried out, the purpose of analysis is to get reliable, reproducible and accurate answers. Now what are the important steps when you carry out a quantitative analysis? There are 4 important stages of any analysis. Number 1 is sampling. Sampling is to select a representative sample for the analysis. For example, you may receive sample in bulk, but that doesn't mean that you're going to analyze the entire sample. You will have to analyze a small amount of sample. Then how do you take a small amount is whenever you are designing any method or using any tool to take a sample, that sample should be a representative sample, or it should have all the essential characteristics of the bulk material. After you have taken the sample is converted into a suitable form or solution for measurement. Then you decide what method to use, and finally you do the calculations and interpret the result and report your answer. Now when you do this analysis, as mentioned above, your analysis or experimental results should be reliable, reproducible and accurate. Now what is meant by accuracy? Accuracy will tell you how reliable are your answers. So it's a measure of how close the observed value is to the accepted true value. Whereas precision, it's a measure of degree of closeness. So it will tell you about the reproducibility of the answer. That means whether you are getting consistent results or not. So out of these factors that are mentioned over here, if it is reliable, generally it is accurate. But if it is reproducible, it may not be accurate. Now what is the meaning of this? Now how accurate is your answer depends upon what is the device that you are using. Say for example, if I ask you what is your age, you may say 18 years, you may say 18 years and 5 months, you may say 18 years and 5 months and 22 days, or 22 days and so many hours and so many minutes and so many seconds. we ultimately stop at seconds, but is it so that you cannot go beyond that? You can go beyond that, provided you have a device to measure milliseconds, microseconds, nanoseconds, and so on. That means whatever answer we give, it is never a true answer. So you never come to know what is the accurate answer. You can only strive to be very close to the expected answer. Similarly, purity of the gold that is mentioned over here, I may have answers like this: 99%, 99.9, 99.99, and go on adding 9 to the next digit, 99.999. It depends upon how accurate is your balance, or rather what is the sensitivity of the balance that you're using. So accepted true value, we have to compromise with true value, and we have to use true value as something that is called as accepted true value, depending upon what device we have. Suppose we have a device only which can give this as the answer, then we accept this as our true value. So true value, real true value, is never known. Now let us understand what is meant by accuracy and precision. Now there are three diagrams in front of you, and if you look carefully, this is nothing but a bullseye game. So the target is the center, as we all know. Now suppose there are three analysts, and all the three analysts are given equal chances. They are given 5 chances, and these are their hits. The dots that you see over here are their hits. Now the analyst may be accurate, may be precise, so you try to rate them based on the accuracy and precision. So you rate them as highly accurate or highly precise, whatever. Just have a look at the diagram and try to rate them. If you are done with the exercise, this could be your answer. This analyst has no accuracy and no precision. The reason is that none of his hits are close to each other, neither they are close to the expected value, which is the center. In the second one, it is low degree of accuracy and high degree of precision. High degree of precision because all the hits are very close to each other. So there is some consistency or reproducibility with regards to the hits. But it's not accurate because it is sufficiently away from the expected hit, that is the center. The third one, as you can see, is highly accurate and highly precise because all the hits are very, very close to the center and they are all very close to each other. So I'm sure you must have got some idea about what is meant by accuracy and precision by using this diagram. Now what do we conclude from this slide is that to know accuracy, one observation is enough. That means if I had given analyst 1 a single chance, and if his hit was here, I can easily say, even looking at one hit, that whether it is accurate or not. But in order to comment on the precision, I need to have set of values. So one observation is not enough for precision. So that's what is mentioned over here. To know precision, we need more number of observation. High degree of accuracy will always have high degree of precision. As you can see over here, high degree of accuracy will always have high degree of precision. But is it vice versa? Is it so that high precision also indicates high accuracy? Not necessarily. High precision can be highly accurate, or maybe having low accuracy, as it is shown in the second diagram. But the reverse is not true. So accuracy denotes the closeness of the measured value to its accepted true value, whereas precision, it is the agreement among numerical values of the replicate set that have been made in an identical fashion. So there is a diagram, or rather there is an illustration here which shows conversation between two students. One of them asking her how was her experiment, and she is looking very sad and says that although my results matched with my friend's results, but ma'am said that my results are not correct. And then her friends are explaining that how her result may be because of an error. The result may have precision but may not be accurate. Now this particular situation may be very familiar to you. You might have also come across a situation where your readings were coming almost same, but when you went to get it checked by your teacher said that the readings are not accurate. And you might have also thought in a similar way that maybe I have got a wrong solution, or maybe ma'am doesn't like me, or maybe she is ensuring that I'm in the lab till 10:30 so that I don't go away early. But that is not a scientific way of thinking. So this happens in any experiment, that you get constant reading but still your readings are not correct, and there is a reason for that. And in order to understand those reasons, you will have to see the second video, which explains about the error in the analysis. I hope you have understood at least the accuracy, precision, qualitative, quantitative analysis, and the important steps in chemical analysis. So we'll see in the next video.